Alright, today we're going to look at solving two-step and multi-step inequalities. At the top of your paper, write Notes 3-4. Your objectives for today are to solve inequalities with one variable that contains more than one operation, and to write an inequality to solve a real-world problem. Alright, go ahead and write down the first problem on your paper. You have number 1, which is 8 minus 3y is greater than or equal to 29. The first thing that we're going to do here is add the opposite. And we're going to make it 8 plus a negative 3y is greater than or equal to 29. Our next step is going to be to start getting that 3y, or that y by itself. So we're going to subtract 8 on both sides. Because we have a positive 8 here, we have to subtract 8, and that's going to give us, this cancels, negative 3y. Is greater than or equal to, and then 29 minus 8 is going to give us 21. So now, because we have this 3 and this y over here, and they're together and they're touching, they're being multiplied, so we have to divide everything in the problem by a negative 3 to get the y by itself. So we're going to divide both sides by a negative 3, and that's going to give us y is greater than, hold on a second, sorry. Sorry, there were two things going on there at the same time. Because I am dividing both of the sides of my inequality by a negative number, it actually flips the sign in the middle, because anytime I divide both sides of an inequality by a negative number, it's going to flip the sign, and it's going to give me it's going to flip the sign, and it's going to become less than or equal to, and 21 divided by negative 3 is going to give me negative 7. So again, because I divided both sides by a negative number here, it gave me a negative, it flipped my sign in the middle and gave me a negative 7. 21 divided by negative 3 is negative 7. So in my set notation, I'm going to say y such that y is less than or equal to negative 7. Alright, so now I have my answer, which is y is less than or equal to negative 7. And now I have solved, I have set, now I have to graph, and then I have to check. So to graph this, I'm going to go ahead and bring in the number line. Here's my number line. Now, because I have an extra mark underneath my inequality sign, I'm going to make a solid circle there at the number negative 7. We say extra mark, make it dark. And then I'm going to shade everything that is less than negative 7. Everything that is less than negative 7. So you're going to shade your number line in this way. Sorry, mine's not very pretty. I'm trying. Just make sure that you can see that you've shaded it less than negative 7. Alright, now to check, I'm going to come back to the original problem. I always go back to the original problem to check. So over here, I'm going to write my original problem, which is 8. And I can go ahead and add the opposite, plus a negative 3. And I'm going to put in parentheses here for my number that I'm going to use to check with. And I'm going to say is greater than or equal to 29. Again, you have to make sure you come back to this original problem to check. So I'm going to pick a number to check with, and it can be any number other than the number that I have shaded here, other than my -7. So for this, I'm going to check with the number -8. I'm just going to go 1 over and check with -8. So I'm going to multiply, following the order of operations, -3 times -8 is going to give me 24. So I have over here 8 plus 24 is greater than or equal to 29. 8 plus 24 is going to give me 32. 32 is greater than or equal to 29, so that checks. Make sure that you have both the work for the problem, the solve, set, graph, and the check written down before you move on. All right, let's look at number 2. Go ahead and write it down. You have -12 is greater than or equal to 2 over 5t minus 2. Now we have this issue here where we look at this problem and we see a fraction and we completely and totally shut down. There's no way we can work that problem because there's a fraction in it. It's not that complicated. And as you may have guessed, we're going to actually show you how to work it out. So the first thing we're going to do is go ahead and try to get our 2/5 t by itself. So our first step to do that is going to be to add our t here. We have a -t. We have to add, we have a -2. We have to add 2 on both sides. So we have over here -2 plus 2. That cancels. Over here we have -12 plus 2, which gives us -10. Bring down our greater than or equal to sign. Bring down our 2 over 5t. And now we're ready for our next step. Now because we have 2/5 t, we have to get rid of this 2/5. We have to move it to the other side of the problem. We taught you the saying that dividing fractions is easy as pie. You flip the second fraction and multiply. So even though you're probably thinking, well, in order to get something away from a variable when they're touching, we have to divide by it. So technically we're dividing by 2 over 5. But because we don't divide a fraction by a fraction, what we do is we flip the second fraction and we multiply by the reciprocal. So our 5's cancel and our 2's cancel, and we're left with t. I'm going to bring my sign down, and over here we're going to do the same. We're going to multiply by the reciprocal. 5 over 2 times -10. When I multiply 5 over 2 times -10, which you're welcome to do if you have your calculators, I'm going to get -25. So this is going to be my answer here. -25 is greater than or equal to t. However, I've solved it, and now I have to set it. So in order to set this, I'm going to say t such that, and my t has to come first in my set, so I'm going to put my t first. But I have to pay attention. My sign is facing away from my t. It's open toward the -25. So when I write it down here, it has to be facing away from my t and open toward my -25. So make sure that just because you flipped your t around, that you also flipped your sign around and you didn't leave your sign the way that it was, because that makes it wrong. I have solved, I have set, and now I have to graph. So draw your number line on your paper. In the middle, we're going to have -25. This way will be -24. This way will be -26. -27. And -23. Okay? Now I'm going to look at my inequality sign. It does have an extra mark underneath it, which means I'm going to have a dark circle here on my 25, my -25, and I'm going to be shading everything that is less than -25. And again, if my inequality is set up correctly, I can look at that inequality sign kind of like an arrow, and it's going to show me that I can shade in the direction that that arrow is facing right here, this arrow. So now I've solved, I've set, and I've graphed. Solve, set, graph. The only thing left is to check. So make sure that when you check, you come back to the original problem, which was negative 12 is greater than or equal to 2 over 5. And again, I'm just going to leave parentheses here for whatever number I choose to check with, minus 2. So instead of the t here, I've just put in parentheses. Now, I can check with any number on this number line in the shaded region except for my midpoint here, my 25. I'm going to choose negative 26 to check with. Excuse me, I'm sorry. I'm going to choose negative 30 to check with. So I'm going to put negative 30 in this parentheses. The reason I've chosen negative 30 is because when I multiply negative 30 times 2/5, it's going to come out to be a pretty number. Negative 30 times 2/5, or 2/5 times negative 30 is going to give me negative 12. And then I'm going to bring down my minus 2. So now I have negative 12 is greater than or equal to, and negative 12 minus 2 gives me negative 14. So that is a true statement. Negative 12 is greater than or equal to negative 14. Make sure that you have all of this down, the work and the check, before you move on. All right, let's look at number 3. Go ahead and get this down. Number 3 is x plus 5 over negative 2, and that is greater than 3. Again, there is a fraction. It is a very large part of your problem. Don't freak out. In order to get my negative 2 out from under my x times 5, I have to multiply. And I'm going to multiply by negative 2, which is the same thing as negative 2 over 1. If it helps you to see it like this, that is fine. You can write negative 2 over 1 because guess what? X plus 5 times 1 is still x plus 5. So my negative 2's cancel. And because I did it over here, I have to do it over here. So I'm going to multiply this side times negative 2. Over here, I'm left with x plus 5. And over here, I have 3 plus negative, 3 times negative 2, which gives me negative 6. All right. Some of you may have realized that because I multiplied, I hope some of you realize this, because I multiplied both sides of an inequality by a negative number, I have to flip the sign in the middle. So I want you to draw that arrow. I want you to show that the sign flipped, and I want you to turn your sign around. And it now says that x plus 5 is less than negative 6. X plus 5 is less than negative 6. Now I have to subtract 5 on both sides, which gives me x is less than negative 11. I have solved. Now I must set. And I'm going to say x such that x is less than negative 11. Now that I have solved and set, I have to graph. So I'm going to draw my number line. Put my negative 11 in the middle, negative 12 down here, negative 13, negative 10, and negative 9. Now, because I do not have an extra mark underneath my inequality sign, it cannot be equal to 11, so I'm going to circle it. And I'm going to shade everything that is less than negative 11. So now I have solved, I have set, I have graphed, and now I'm going to check. In order to check, I have to come back to my original problem. And instead of x, I'm going to put in parentheses. And I'm going to say parentheses plus 5 divided by negative 2 is greater than 3. I'm going to use negative 12 to check with. Now, negative 12 plus 5 is going to give me negative 7 over negative 2. is greater than 3. Negative 7 divided by negative 2 is going to give me positive 3.5, which is greater than the number 3. So this is how it checks out, and it is a true statement. Alright, go ahead and get this down. Number 4 is 1 minus 2n over 3 is greater than or equal to 7. This one is a whole lot like the last one that we did. So why don't you go ahead and pause the video here and attempt this one on your own, and then I will show you the answer in just a moment. Okay, I want to make sure that you have solved, set, graphed, and tried to check this answer. So if you have not done that, go ahead and pause the video and go through all of those steps for me. Okay, again, because you have tried this one on your own, I'm not going to insult you by going through it all. The one thing that you may have missed here is that when you divided both sides of an inequality by a negative number, you had to flip the sign in the middle. So at that point, it went from being greater than or equal to less than or equal to. So make sure that you got all of this down correctly. You should have gotten in as less than or equal to negative 10. You should have a solid circle here. It should be shaded to the left. It should be shaded less than. And then if you checked with negative 11, you should have gotten 7.67. But if you checked with anything else in the shaded region, you should have still gotten a true statement. So if you made a mistake, figure out where you went wrong and get that corrected before you move forward, please. All right, go ahead and copy down number 5. Number 5 says 2 minus, open parentheses, negative 10, close parentheses, is greater than negative 4t. Okay, I hope that we know by now that when we have minus and negative, it means nothing other than we're adding. 2 negative signs together make it a positive. So this is actually the same thing as saying 2 plus 10. And 2 plus 10 is 12. I'm going to bring down my greater than sign, my negative 4t. So now, because I have a negative 4t, I have to divide both sides by a negative 4 because these are being multiplied. I have to divide to undo it. Because I divide both sides of my inequality by a negative number, I have to flip my sign. Positive 12 divided by negative 4 gives me negative 3. And negative 4 divided by negative 4 cancels, and I'm left with t. So I have negative 3 is less than t. That is solved. Now I have to set. In order to set, I have to put my t first. So I'm going to have to flip around the entire inequality. And again, the simple thing for me here is to look at what my inequality sign is eating. If my inequality sign is eating the t up here, then even though I turn it around, it still has to be eating the t. So I have t is greater than negative 3. That is my set. Now I'm going to graph. Negative 3 in the middle. For here I'm going to put negative 4, negative 5. Up here I'm going to put negative 2 and negative 1. So because I have no extra mark, I know that t is not equal to negative 3. So I'm going to do an open circle at negative 3. And because I can look at my inequality sign as if it's an arrow, it shows me which way to shade because I have done my set notation appropriately. So I'm going to shade this way. Everything greater than negative 3. I'm going to choose something within that region to check with. And in order to check, I have to come back to my original problem. And I'm going to say 2 minus a negative 10 is greater than negative 4 times t. Again, I'm going to put in open parentheses there, and I'm going to choose something from the shaded region. In this instance, I'm going to choose negative 2 to check with. So I know that 2 minus a negative 5 is the same thing as 2 minus a negative 10 is the same thing as 2 plus 10. It's greater than. And then negative 4 times negative 8 gives me, negative 4 times negative 2 gives me positive 8. I'm sorry, I'm talking a step ahead of myself here. 2 plus 10 is, again, 12, just like it was a second ago. And negative 4 times negative 2, again, gives me 8. So 12 is greater than 8. That is a true statement. 12 is a bigger number than 8. So it does check out. And I know that I solved, set, graphed correctly. Make sure that you get all that down before you move forward. All right, let's take a look at number 6. This is the last one that we're going to be doing that looks like this. The first thing we're going to do here is bring back those arrows that we all love so much, and we're going to have to distribute this negative 4. Make sure that you have this problem down. It is negative 4, open parentheses, 2 minus x is less than or equal to 8. As soon as you get the problem down, I want you to go ahead and draw your arrows. All right, and again, those arrows are just showing that we're distributing this negative 4 to everything inside the parentheses. So that gives me negative 4 times 2, which is negative 8. And negative 4 times negative x, which gives me positive 4x. Because a negative times a negative is always positive. So now my problem should say negative 8 plus 4x is less than or equal to 8. My next step is going to be to work on getting my 4x and eventually my x by itself. So I'm going to add 8 on both sides. This cancels. And I'm left with 4x is less than or equal to, and 8 plus 8 is going to give me 16. Now I know that when a letter and a number are touching, they're being multiplied, so I have to divide in order to undo my multiplication. I'm going to divide by 4, and it's going to give me x is less than or equal to 16 divided by 4 is 4. So now I have my problem solved, and I'm going to set it, and I'm going to say x such that x is less than or equal to 4. I have to graph. I'm going to draw my number line. My 4 in the middle. Up here I'm going to put 5 and 6. Down here I'm going to put 3 and 2. Because I have a extra mark underneath my inequality sign, I'm going to make a dark circle, extra mark, make it dark, a dark circle here at the number 4. And I'm going to shade, because my set notation is done correctly, I can look at my arrow and see which way I'm going to shade. My inequality sign functions as an arrow. And I'm going to shade everything less than 4. To check this problem, I'm going to come back to my original problem, and I'm going to say negative 4, open parentheses, 2 minus, and I'm going to put more parentheses here for whatever I'm going to substitute in for x, less than or equal to 8. Now I'm going to substitute in one of those numbers in my shaded region down here for x. For this problem, I'm going to choose the 3. So what I have here is negative 4, open parentheses, 2 minus 3, close parentheses, is less than or equal to 8. Now I'm going to work what's in the parentheses first, because that's what the order of operations tells me to do. So I have 2 minus 3, which gives me negative 1. It's in parentheses. I have negative 4 outside the parentheses. And then an 8 on the other side. Negative 4 times negative 1 gives me positive 4. Positive 4 is less than or equal to, it's less than 8. So that does check out. It is a true statement. Make sure that you have all of this work copied down before you move on. I'm sorry, guys. I did not intentionally lie to you. This is the last example we're going to look at like this. So there is one more of these that we have to do together, and then we're going to do one ace, and then we're going to do one word problem that we ace in class tomorrow. So go ahead and get this one down. It's 3 plus 2, open parentheses, x plus 4, close parentheses, is greater than 3. This one's a lot like the one we just did, except that we have this extra 3 out here in the front. So we have to get rid of that 3 as well as distributing the 2 to everything inside the parentheses. So the first thing we're going to do is distribute our 2, because that's what the order of operations tells us to do. And that gives us 2x plus 8. Because 2 times x is 2x, 2 times 4 is 8. And then I'm going to bring down my 3. Now you may notice that aside from the inequality sign here in the middle, this looks a whole lot like some other equations that we've worked. I have a 3 and an 8 over here on the same side of the problem, and they are like terms. So don't get confused here and try to subtract 3 from both sides. I'm just going to go ahead and combine my 3 and my 8. 3 plus 8 is 11. 3 plus 8 is 11. I'm not even going to rewrite that to get confused. I'm just going to say 2x plus 11, because 3 plus 8 is 11. Bring down the other side of my inequality. Now I have to subtract 11 from both sides. This cancels, and over here 3 minus 11 gives me negative 8. Bring down my inequality sign and my 2x. I know when a letter and a number are touching, they're being multiplied, so I have to divide. In order to undo that, I'm going to divide by 2, which gives me x is greater than negative 4. I've solved. Now I have to set. Draw my squigglies, my x, such that x is greater than negative 4. And now I'm going to draw my graph. My negative 4 goes in the middle. Down here I'm going to have negative 5 and 6. Up here I'm going to have negative 3 and negative 2. Because I have no extra mark underneath my inequality sign, I'm going to make an open circle here at my negative 4, and because my set notation is set up the right way, I can look at my inequality sign as an arrow, and I know which way to shade. I'm shading everything greater than negative 4. I've solved, I've set, and I've graphed, and now I have to check. I come back to my original problem in order to check. And here I'm going to plug in a negative 3 for x. So I've got a lot going on over here. The first thing I'm going to do is what the order of operations tells me to do, which is what's in parentheses. Negative 3 plus 4 gives me 1. So this 2 times 1 gives me 2, plus 3 is 5. 5 is greater than 3. That checks out. That's a true statement. So I know that I have solved, set, and graphed correctly. Make sure you have all that down before you move on. Alright, so now we know that you can solve inequalities with one variable that contain more than one operation. Now we're going to look at writing an inequality to solve a real-world problem.
Alright, this one says, when could I ever use this? It says the average of Jan's 2 9 weeks grades must be at least a 93 to make an A in Algebra 1. Jan earned a 97 the first 9 weeks. Determine what grades Jan can get the second 9 weeks to make an A in the class. And we're actually going to ace this one, so you need to go ahead and write an answer, a cite, and an explain. Go ahead and make your boxes for those. Alright, so again I have my answer, my cite, and my explain, and a calculate. So the first thing I'm going to do is I'm going to turn my question into an answer. And it says, determine what grades Jan can get the second 9 weeks to make an A in the class. So I'm going to turn that into a sentence answer. The grades Jan can make the second 9 weeks and make an A in the class are blank. So that's my A for my answer part. Then my cite, again, is just what's important in the question. The important thing is the fact that the average has to be at least a 93 to make an A. and the fact that she earned a 97 the first 9 weeks. Those are important. So in the site, I'm going to write the average must be at least a 93, and Jan made a 97 the first 9 weeks. I need both of those pieces of information in order to come up with my answer. So now we're going to look at what does it mean to average. If we're going to average two things, it means that we need to add them together and divide by 2. So averaging is adding up the number that you have and then dividing by however many that is. So here again we have 2 grades, so we're going to add them and we're going to divide by 2 because there's 2 grades there. So we're going to set this up and say 97 plus G divided by 2 is greater than or equal to 93. Because we know that she had a 97, plus we don't know what her second 9 weeks grade is, so we're going to put a variable G for grade. And we're going to divide that by 2 to take the average, and it's got to be greater than or equal to a 93. So now we're going to solve. So I'm going to multiply both sides by 2. And we usually do our adding and subtracting first, but here, since the entire thing is being divided by 2, I have to multiply by 2 first and move the 2. So I multiply both sides by 2 and I get 97 plus G is greater than or equal to 186. Then I'm going to subtract the 97 from both sides and get that G is greater than or equal to 89. And in my explain, I write at least is greater than or equal to, and to average, I add the 2 grades together and divide by 2. And then I'm going to go back and answer my question. It says the grade Jan can make the second 9 weeks and make an A in the class are greater than or equal to 89. So she can make an 89 the second 9 weeks and get an A, or she can make greater than an 89 the second 9 weeks and earn an A. Again, your explain might have been a little bit different than this. You could have also went through and told what you did in your calculate. You could have said multiply by 2 and then subtract the 97. But again, you need to make sure that you have the answer, cite, calculate, and the explain part written for this one. Tomorrow we're going to look at another one similar to this, and we're going to ace it in class. So make sure that you bring your notes with you. Alright, this is the one we're going to do tomorrow. Give me just a second. Alright, so now we've covered both of our objectives for today. We've solved inequalities with one variable that contain more than one operation. And we have been able to write an inequality to solve a real-world problem. Alright, this is the end of your video. Thank you for watching.